Many students struggle with signal flow graph because it looks like a bunch of arrows and confusing circles. But by the end of this video, you'll be able to identify a forward path, a loop, and even know how to solve problems using Mason's game. What are signal flow graphs? Signal flow graphs is any diagram that is used to represent a set of simultaneous equations. They consist of nodes. Take for example, what you are seeing on the board here is a signal flow diagram or a signal flow graph. Now it consists of, every signal flow graph consists of nodes. What are the nodes? They are represented by dots. So this is a node, x1 is a node, x2 is a node, x3 is a node, x4 is a node, x5 and x6, they are all nodes. So it consists of one, a node, two, the nodes are connected by a directed line. That directed line is called a branch. So if you look at these two nodes, they are connected by a line. This line that you are seeing here is called a branch. Also in between 2 and 3 is connected by a line. That line too is also called a branch, and so on. Now that branch consists or carries an arrow. That arrow indicates the flow of signal. So if you look at each of these branches, you can clearly see that there are arrows drawn on there. So every signal flow graph consists of those four. You must have a node, you must have a branch, and the branch must have an arrow. And on the arrow, you will see this alphabet. This A12, A23, A34, and so on. They are all called gains. So you can call them gains or you call them transfer functions. So every signal flow graph consists of a node, also it consists of a branch, it consists of an arrow and a gain. So let's look at the terms that are associated with signal flow graph for us to properly understand this. So these are the terms associated with a signal flow graph. So let's start with the first one. The first one is a source or input nodes. What are source or input nodes? Source or input nodes are simply nodes that have only outgoing branches. Let's look at these nodes together. We've already established that x1, x2, x3, x4, and so on, they are all nodes. So which of these nodes have only outgoing branches? And that node is x1. So if you look at x1, it only has, by the arrow you will know if it's an outgoing or incoming branch. So if you look at x1, it only has outgoing branches. So under this source or input node, I'll put x1 based on my diagram here. Now let's go to the next one, the sink or output node. So for sink or output node, there are nodes that have only branches. So if I look at all my nodes, see x6 only have incoming branches, which is this. By the arrow, you can see that it's incoming, it's coming towards this particular node. So that is x6, our node is x6, and that node is our output node. Now let's move on. We have mixed node. Now for mixed nodes have both incoming and outgoing branches. If you look closely, see x2, x3, x4, and x5. They have both incoming. See the arrow? You have the one coming in and you have the one going out. So for x2, I have both something coming in and something going out. Same thing with x3. I have something coming in and something going out. So that's why we call them mixed node, because they have both incoming and outgoing branches. So if I want to list all of them, I'll have under mixed node, I have x2, x3, x4, x5. These are the mixed nodes. Let's go to the gains. I've already explained what gains are. Gains are simply, they are resting on the arrows in a branch. Look at the arrows. A gain is always anything that is resting on that arrow in a branch. So this is a gain. These are gains, including this. They are all gains resting on the arrow. So I have A1, 2, A23, A34, etc. So they are much. So we have all these are gains. Now if I don't want to call them gains, another name I can call them is called transfer functions. So they're either called a gain or they are called a transfer function. So moving on, forward path. What are forward paths? Now, forward path is a path that starts from the input node and end at the output node. Any path that starts from the input and ends at the output. So let's look at this diagram carefully and identify the forward path. So I can clearly see that I have one forward path already here. Here's a path that is starting from here and going all the way to the output. Remember, that's the meaning of the forward path. It starts from the input and ends at the output. So let me write that one out. We have from x1 going to x2, going to x3, going to x4, x5, and x6. So this is a forward path. From x1 to x2, from input to output, you have a forward path. Let's look closely. Do we have another forward path? Do we have another forward path? Yes, we have another forward path. You can see that based on the arrow, it's something like moving to the output node. So I have another one. Based on the arrow, I am moving like this. This moves to this. Then I have from this to this. So see the arrow is going forward. So I have it's starting the path is starting from here, moves like this. Why am I not going this way? Because this is moving backward, so it's not a forward path. You are picking only the one that the arrow is taking me to the output. This one is taking me back to the input. Remember, a forward path starts from the input and takes me to the output. So I'm starting here, moving here, then it took me to the output. So that is another forward path. So we have from x1 to x2 to then x5, sorry, not comma, taking me this, then finally to x6. So you skip x4 because it moves from x1 to x2 to x3, then x5 to x6. Let's check again carefully. Do we have another forward path? Yes, we have a forward path. So we have um from here to here, from here to here, from here to here, then go up, then we continue. So that's the forward path. So I will just put etc here. I think in this diagram there is a little mistake. It's supposed to be this way. It's supposed to be that way, the opposite. So if it's moving backward, this is not a forward path. Pardon me. This is not a forward path. So I believe these two are the major forward paths that we can observe from this place. They are really forward paths we can see. So let's go to the next term, path gain. The path gain is the product of gains on that path. So picking this forward path that we have talked about now, the path gain is simply the product of all the gains on that path. So this first part we just talked about, x1 to x6. If I take the product of all the paths, I will have a1, 2, a2, 3, a3, 4, a4, 5, and a5, 6, etc. Same thing applies here. I will take the product of all the paths. Then we call it the path gain. So moving on, we have a loop. A loop is a loop starts from a node and ends at that same node. So if you look closely at this diagram, let's identify the loop. Any loop, it starts by the arrow you will know. It starts from a node and returns back to that same node. So if I look at this place, I have a loop. Why? Because it starts from here, it moves to this point, but it returns back. So this is a loop. Let's check again. I have another loop from here, starts from here, move to this place and returns back. That is a loop. Now, is this a loop? It starts from here, moves to this place. Does it return back? No, it doesn't. Based on the arrow that is here, you can see that it's still moving forward. So this is not a return, it's not a loop because it doesn't return back. The arrow is telling that it's going this way, so this is not a loop. A loop must start at a node and return back to that same node. So if you look at this, this is also a loop. It starts from here and returns back to this node. So we'll just pick this one and we'll put an etc to continue the rest. So the loop there is from x2 to x3. I can still take another one. We also have x3 to x4, etc. Let's go to safe loop. Safe loop is still similar with a loop, but it doesn't move to another node. It returns to that particular node. There is no movement. It starts from a node and return back to that node. It doesn't move to another node like this one. This one, at least it moved from here, went to this node, but it came back. But a self loop, it's on itself. So you have this particular loop. See, it starts from here, it moves back. So that is a self loop. So the only self loop, we only have one self loop, which is this on X4. So for loop gain, what are the loop gain? The loop gain is simply the gains on that loop. So we picked this one, we said this is a loop. So what are the gains? This is the gain, this is a gain. So it's the gain on that loop. That is a loop gain. So this is the gain, this is the gain. The gains on that loop is a loop gain. So we have A3 to etc. Now, what are touching loops? Touching loops are loops that are connected or they have common nodes. Any loop that have share common nodes are touching loops. Let's look at these two initial loops that we talked about. We talked about this loop, right? Are they touching? Yes, because they are sharing a node, X3. So touching loops are loops that have they are sharing nodes. They have common nodes with each other. That's a touching loop. So these two loops are perfect example of touching loops. So that is the loop is x2 to x3 and x3 to x4. Let's check if we have non-touching loop. Now non-touching loop, they don't share any common nodes. If I look at my diagram carefully, do I have any loop that don't share a common node? Yes. Remember, this is a self loop, right? This is a loop. My nodes are x2 and x3. My node here for this loop is x4. Are they sharing any node? They are not sharing. So, and this loop are not sharing. But is this loop sharing a node with this loop? Yes. So this is a touching loop, but it's not a non-touching loop. A non-touching loop refers to this one and this one. So, which is x2 to x3 and x4. So these are the terms that are associated with our loop. So I believe with this understanding, you should be able to identify anywhere you see a forward path. Be able to also identify any loop you find, identify any parts of these terms that we have talked about. Then in our next video, we'll be looking at construction, how to construct signal flow graph from simultaneous equations. Thank you, and I hope you enjoyed this video. If you learned something, please remember to subscribe, like, and share with your friends. Thank you. See you in our next video.